Well, hi, good morning. Thanks so much for coming and keeping me company here while I work away on this radio. And thank you to at least one of you, and maybe more of you have commented or told me that maybe I should have thought a little more about the LEDs in this radio, and I think you're right. So I've put 3 LEDs in here to replace the old light bulbs that were in there. And I've done this before a couple of times, but I did it this time on a 14 volt supply from the transformer here without thinking too much about the reverse voltage withstand capability of an LED. So we're going to look into that first thing this morning. The LEDs I'm using, I guess these are cheap no matter where they come from, but I certainly didn't buy top of the line LEDs, so perhaps the reverse voltage withstand of these is actually lower than average or on the weak side. I don't really know, so we're going to look into that right away. The solution's quite simple. If in the end these things really can't take 14 volts in reverse, then I can stop that by sticking a stronger regular diode in the circuit here and eliminate the AC going to the LED. So something I just didn't think about. So let's take a look at that first. What is the withstand voltage of these LEDs? Now, I didn't get any information with them, so we're just going to have to look on the internet and see what Mr. Internet can tell me. Okay, so LED reverse voltage withstand. What is it? People ask, what happens if you put an LED in backwards? A generic 20 milliamp LED has a safe maximum reverse voltage of only 5 volts. Oh my gosh. In a system with higher voltages, even a resistor to limit the current, say to 1 milliamp, will still not protect the LED. Okay, so I made a boo-boo here for sure. LED in parallel the other way. So if I put an LED, if I take an LED or a diode, let's say a diode, and put it in parallel with the lights and put it the wrong way, it's essentially a 0.7 volt short circuit on the transformer here. That doesn't sound like a good idea. So you'd have to put in a resistor to control the reverse, the reversed forward current. Yeah, I don't like that idea. I think it might be better. I've got 14 volts to work with. That's lots of voltage. Put a diode in, make a little power supply out of the deal here, and supply the LEDs with a more appropriate DC type arrangement. I got to dig around my parts and get a few things out here to do this. Okay, so what I've done is I've stuck a diode into the circuit here. It's just in series with the resistor and the like. The lights are still glowing. I thought, oh, that's kind of interesting. Let's see how much current is actually flowing in here. I have a clamp-on DC meter, which I zeroed before I set it up here. It's saying 50 milliamps. It's saying 5.5 milliamps is what it's saying there. Oh, that's not very much at all. So these are 20 milliamp lights, if you like. There's 3 of them, so you could have 60 milliamps flowing in here. If I got that right? Huh. I think it's 60. Okay, so if that isn't confusing enough for me, I didn't. If you can see, the black lead here is a scope lead. I put the scope lead right across the diode, expecting to see a nice clean display on my scope here. Not sure you can call that a nice clean display there. There we go. Yeah, so it's not at all what I was expecting to see across it. The scale here is only 0.2 volts per division, so you're not even talking a volt up to here. I don't know what to make of that thing. So, but the main thing is, if you just ignore all that stuff and look down here, the lights are on and they look good. They look good and bright. They don't look too bright. It all looks good, so that's enough on the lights. Now, I gotta think of what to do next with this. Okay, so I was just getting things ready. I decided the next thing to do with this, play the radio and see what it sounds like. And so I brought over the original speaker. Actually, this isn't the original speaker. This is a replacement speaker that the owner has put in very nicely. And here's the speaker output wires. You see one clip lead. I was putting the other clip lead on. Have a listen. So, what's that telling me? Well, let's turn this off. I think that's telling me there's a DC voltage at the end of these wires. And you don't want that. I'm pretty sure that's not the idea. So let's just take a look at that possibility. I'm actually going to hook up a voltmeter right to the speaker here. Such a crazy idea. I've never done anything quite like this. You know, this is a transistorized device, so its behavior is a little different when it comes to exactly this kind of stuff. Oops, let's put this up. My expectation is this would say 0. I'll put it on 20 volts there. Okay, no speaker connected, just the voltmeter. Turn it on. Look at that. Minus 10 volts. So now, is it the case that when I hook the speaker up, the 10 volts disappears, and that's the end of it? So it's just a charge, discharging, and that's what the pop is, and I shouldn't be worried about this at all. Is that really the case? Here, let's hook up a speaker I don't really care much about, and see if the voltage disappears. You should hear the pop down here too. The voltage. Oh my gosh! Now let's do this. Let's hear that funk. Let's watch the cone. Where's the cone end up? How are we going to do this? How am I going to do this? Okay, don't need the voltmeter. Don't need the voltmeter anymore. So, you know, if this pops up and goes back, okay, kind of. But if it pops up and stays up or down, not good. Here we go. What is happening there? It's making the lights flash. It's making the LED lights flash. This is the speaker wire, right? Yes. I got quiet suddenly there, right? It's got to be the speaker wire. It has to be. Come on. Okay, let's try it again. We got to get a closer look at it. We need a much closer look at what's going on here, because maybe a big charge, because there's a potential for DC leak in the receiver, and so without a speaker connected, that potential builds up in something, maybe a capacitor or something. Hook it up, voltage collapses, speaker gets a shot, but the voltage doesn't go to 0. It goes to some lower number now that the speaker's hooked up, and is actually displacing the cone. That's what I'm trying to find out. Let's look through this camera and see if we can't see a rise or fall in the speaker. Here we go. It doesn't seem to do that. It seems to make a sound but not really go anywhere. Let's watch it again here. Wait a minute. Yeah, you know what? I think it's pulled downwards. Let me get a better grip. I'm having some trouble making connections. Here we go. So I'm watching it right up in this edge here. Well, right over here is what I'm watching. Come on. What's with the wires here? It's really not easy to do. I had to put a switch in to make this work right. Oh, that was a little different. Where's the hum coming from? Okay, that's two things now. They're a little wacko. me turn the radio up so we can actually hear the radio working too. If I can. Okay, don't know how loud to turn it. How loud did I turn it? Okay, we should be able to hear something from the speaker now. Let's get back down here. I don't know if this is really going to work out. Okay, Mr. Speaker. Okay, there I hear it. Slight upwards movement of the speaker cone when the wires are attached. That's what I see. You can do another simple thing, and that is look for DC voltage when the speaker's connected and see if there's something like that going on. Let's continue with the junker speaker here rather than risk the valuable one. So I'll just put this on. So lots of transistorized amplifiers can have a problem with DC going through the speakers. And the symptom is exactly what's happening here. Those clicks. Now you can't normally hear those clicks because you're not normally hooking the wire up on and off your speaker. Okay, and we can hear it a bit. Ooh, what's happening here? What is happening? What was happening there? Son of a gun. Okay, one of the things I want to do here is I'm going to take the scope off. I shouldn't really have left it connected. Let's take it off. Because the scope has a ground lead, I have to be conscious that I've connected a ground into the middle of the circuit, so to speak. Take that away. Not to worry. Okay, speaker voltage. Speaker voltage. Speaker DC voltage. This is what I really should have done right from the start, I guess. So we're looking for DC voltage. It looks pretty tiny. So there is something there. What's it doing? Jumping around. So, you know, there's an AC thing going on here. Now it's not jumping. But, okay, so that's about. Now it is. You know what? It's my voltmeter. Is it? Ay. What's going on? So on the 20 volt scale we get, that would be how do you give me 20 volts on here? I'm losing my mind here. On the 2 volt scale. On the 200 millivolt scale. Now it's almost gone to nothing. Maybe I'm worried about nothing here. Without the speaker connected, a little DC voltage building up somewhere. With the speaker connected, that voltage can't build because the speaker's there draining it all the time. And that's what you end up with. The tiny volt. Why do these things happen to me all the time? What was that? I'm trying not to move. Well, it seems stable now. What happened there? Oh. Now that's real interesting. Okay, so what we got a chance to see there was the voltage when I open circuited the speaker. Let's do this again. Put it on 20. I'm going to open circuit the speaker here. This is probably not an important observation, in fact. So it's going to rise up probably to the power supply voltage. That's probably what's happening. And then when I hook up the speaker, it just drains that voltage away real quick. I wish I was just a little more familiar with transistor amplifiers. I think that's the story here, though. It's unimportant. I noticed something because we're hooking up and disconnecting the speaker. That's an unusual operation. The engineers will not be concerned that it's going to make the speaker click when somebody does that, because they assume the speaker is always connected. That would also mean when the speaker is not connected, that voltage is floating high, and what it's doing to the output transistors or other circuits. Maybe my earlier statement about not having a speaker hooked up is false. I didn't think it was too critical in a transistor. Yeah, this is a low power. If you're dealing with a high power amplifier driving big speakers, then you're talking a fairly high output voltage and everything gets more critical. This little one probably not so critical. Okay, it's time to listen to the radio then. I think I finally got there. Let's hook up the real McCoy speaker. What those other hums and stuff was, who knows? I don't. If they don't come back, that's fine. See, even there, I don't know if you noticed, the speaker clicked just from the residual charge in here. We're hooked up, power on. There's just a little bumping sound in there. That's probably the same thing happening. It's probably a rising DC. Push the cone for a bit. Okay, enough of that daydreaming about what's going on. Let's see what's really going on. So we're switched on. What are we switched on here? We're not switched on anything. Down. AM radio. Can we tune this guy? Nope. We cannot. So the scale is backwards. The low end is over here. So 860 is going to be right in here. Can we get a French station? That's excellent. Okay, that's excellent. Now we'll check FM. FM. I really need to put some kind of antenna on it. Anything at all will do. We'll put this on. Just anything's better than nothing here. Let's try that. What's that? Beautiful. I'll go down to the talk station. Oh, where is it? Talk station's at 90. 91.5. Wait. Oh. Sounds great. It sounds excellent. I can't pick up the talk station. That should be right in here. Don't worry about it. The fact is, radio works great, and I'd be stupid to fiddle around with any of it any further, because I mean, really, how much better can it be, really? So now we're down to another mechanical issue, and that is getting this to attach properly. Now I notice there's two screws here that are missing. They didn't come with it. That's probably the main problem. Well, what did they screw into? They don't screw into anything here. Well, isn't that odd? So these screws come right up against, there's a hole here for the screw to kind of clear this, and then over here it's run into this piece of material. There's a hole in behind here, you can't see. This looks like old cork or something here. Maybe that's tape. Maybe this is old tape. Yeah, that's what it is. They originally taped this thing on. They used basically double-sided tape. Taped it in place. So what are those screw holes for? They must have something to do with the cabinet. There must be something about this in the cabinet. Okay, well, the cabinet's right here. Let's take a look. Kudos to the owner of this for the speaker he chose to put in here. It really sounds great. Probably better than the original. Okay, so, well, there's where in heaven's name would a screw go there? Nowhere. How's this work? Let me look from behind. That's really strange. No wonder the screws aren't in there. Is there something missing? Something missing from here? So these screw heads get covered by the cabinet. They must be screwing through into something. Would it be bolts? Was there nuts and bolts on the back of it? Was it screws into another model of cabinet but can't screw into this one, so they taped it in place? The owner attempted to glue it back around the top edge here, but I don't think there's enough to really catch it. I think the real area to glue it is down here. Gluing it, yuck. Yuck on that. Now, chances are when you put it in the cabinet and put it all together, this thing gets pressed up against here. So it could be the purpose of the tape was to hold it in place during manufacture, so when this went in the cabinet, this thing wasn't falling out. So you temporarily kind of tape it in there, temporary, permanent. Maybe that's what they did. And these are just forsaken because they don't go anywhere. Why is everything so difficult? Can't they make these things just more obvious? Why do they do it this way all the time? Okay, so I'm going to stop for a while because it's a good time to stop and think. And after I think, I'll come back and then I'll be ready to make the mistake. Great. Okay, let's approach this from another angle. We'll look at the cabinet itself, and the first thing I see is the owner, as he mentioned to me, he tried gluing this in, and I think the idea was sound. I think he just picked a bad choice of glue here. I'm not even sure what this is, but it's just really not adhering. And this is a pretty rough surface down here, and it's just all flaking off. And of course, it's going to have a hard time adhering to. Well, it would adhere to this because the old tape is here. Likewise, there's tape up here, so I guess it maybe, I don't know. There's no real surface here, is there? Hey, let's put this in. Let's put this in the right way. So this is the bottom. So the bottom should be towards the bottom. Should be like that. Drop it in. Well, so its positioning, it has lots of play here. Positioning is really dependent upon these knobs are really what's controlling the position of this thing, these buttons. So if you were to attempt to glue it, you can't glue it ahead of time. That would be a disaster, because you might get it glued, on an angle or too high or too low. So you kind of want to, oh boy, I think all this has to come off. And what's really required here is a very small amount of glue, just a few little dabs here and there, I think would be sufficient. Yeah, this is going to be a bit of a problem. While I've got this out, you can get a really good look at the FM antenna. So that's the plug that goes into the receiver. When you see these large aluminum sheets here, another one over here, you can see it comes around. Maybe that's to achieve the necessary length. This is basically an FM dipole antenna. The interesting thing to me, and I don't understand this, I've never really looked into it, but most antennas are just skinny little pieces of wire. This has got a wide piece, and it's very common to find this done in radio. So exactly what goes on with a wide piece here as opposed to a wire, I don't know. They can see this fantastic looking coil down here between the two halves. So it's an engineered thing for sure. This is no slap together deal. Somebody thought it through. And yeah, so I'm gonna have to I think the steps are clean it up, get this sitting on the radio properly, get the radio into the cabinet properly, and then what? And then I've already got glue in here, and then I press it up somehow. Yeah, okay, time to think a little more about that. Make sure I get this procedure right. And you're working with glue. Sometimes you only get one shot at things. Okay, how about a brand new challenge? The pull tab broke off our milk. So how do you get that out with a pull tab on it? Never had that happen before. Get a knife. Oh, that was easy. Okay, onward. Okay, so I've given this some thought. I think the first run at this I want to take, cleaning off all this little bit of glue here, is the double-sided tape thing. I'm just going to duplicate what I believe was done originally. Put double-sided tape along here, stick it onto the chassis, put the whole thing into the cabinet. I think one of the concerns here might be light leaks from the LEDs I put in, which are no longer coming through this front panel in behind the white. They're actually right back here in the radio now. But what can we do about that? Occasionally a light leak actually looks nice. Maybe not in this case though. So that's the approach. Double-sided tape, which I hate working with. Let's do it. separated here. How lucky is that? That's lucky. There we go. Okay, step 2 is to put this back on the front of the radio. Right. Oh, I still got this pointer not working problem. You know what? I'm going to hold off right now. If I stick this on the front, I can't get access to any of this. It's hard to turn the wheel. Let's just stop at this point. Go back to trying to solve the pointer travel problem. I've been coming at this like it's a problem of lubrication or resistance in a rotating part. It still feels like lots of resistance. So is it really the capacitor here? Oh, someone's calling me. Okay, now I'm really interested in figuring out exactly where the friction is in this system. And I'm obviously quite suspicious it's the main capacitor, of course. So what I'm going to do is I'm going to relieve the tension on here so I can turn this, and all I'm feeling is this with my hand. I don't want to feel any of the rest of this. So I'm just going to pull the string off here. Let it relax. Oh yeah, so it really doesn't feel impossibly stiff, but it's not totally loose. It's just possible they built this capacitor so it never is totally loose. It has a, I noticed it earlier, a bit of a plastic bushing in here which may have been intended to provide sort of anti-backlash type, or just, now that feels a lot harder to move, like a lot harder, and all I'm doing is just dragging point. I also see the spring taking up tension here, see it expanding and contracting. So that's a little odd because I'm pulling both ends of the string here. What is that telling me? That the spring expands a bit. I can't imagine what else is in here to cause tension. There's a lot of small pulleys, but these usually really don't have any problem with them. Here it is. It turns freely. Fingers away from there. Yeah, it turns just fine. But how much? It's hardly even on this. I think I've seen these turn. Yeah, both turning. It's got to be the main capacitor. So what more can I possibly do about this thing? This is not a strong spring, but part of the pull is against this spring. So if I were to relieve this tension here, we'd probably find I gotta do that. So I'm going to temporarily take the tension off here and then see what it's like. Okay. I'm going to dial this guy here and see if it's... Oop, that's the volume control. So I see it makes no real difference. So it's not related to the spring, the FM tuner. So we're just down to this guy. So what would my options be with this? I've already WD-40'd it quite a bit. Did I miss something in there? I don't think so. I think it has to do with this. And what I'm guessing is that plastic sleeve deal. So I could put more solvent in. See, it feels a lot looser up at this end. Hard to say though. Feels like it's getting tighter and tighter, but actually this spring is relaxing. It's actually helping me. Right now it's helping me pull. Chances that did I ever test this knob itself here? We'll do the same thing. We'll take the tension off. It's trickier said than done. Let's go right to the end of the capacitor. There we are. Take the tension off. It turns quite freely. Now watch this. It's going to work now. Okay, this feels totally different. This feels different. What happened exactly? I don't know. What did I do to it? I just took the tension off a couple times. Working pretty good now. Well, maybe I just hadn't worked it enough until now. Maybe if it sits for a while, it gets a little sticky and you need to work it a couple times. Now, the problem is when this is back in the cabinet, if it ends up stalling and turning this won't free it up. If it's stalled and you need to exercise, you'd have to reach in the back and turn this thing by hand, which is probably pretty darn awkward to do. So rather than wear my wrist out here and make a very boring video of me dialing this back and forth, it's really quite good now, isn't it? I'm going to stop, let it sit for a while, and see if it sticks again after sitting. And put it roughly in the middle. Okay, break time. Just on further reflection, I think I'm going to try to give this guy some shots of alcohol here. The thing about alcohol is it completely evaporates, so it's if I can get any of it to get into that bushing. The other thing about alcohol is, it's not so bad to drip it around. And holy smokes, this just feels incredibly loose now. That couldn't have been the alcohol that fast? No way. No, maybe it just... Maybe what? So in my imagination, I can picture the alcohol kind of getting in that bushing a little bit, loosening everything up, and then over time evaporating away and everything tightening up again. But I had WD-40 in there also, so the oil from the WD-40 will remain. This feels much better, and I don't know if it's the alcohol I stuck in there. Now, make this easy. I'm going to put the knob on. What's going on there? Back it all the way out. It feels very different. Of course, I have this big knob on here now, so that it'll give me a very different experience. Well, I don't think there's any. I think it's a great. I think we may have solved that problem. Solve it or solvent it. I think we solvented that problem. That's my pun for the day. Now, yeah, that's great. Okay, problem solved. Light's done. Stick the front on. Let's stick the front on now. Is this the right time to do it? Stick the front on. The thing is with the tape here, I can pull it off anytime I like. So I did not remove all this glue. That is kind of, it's kind of snotty stuff, if you know what I mean. Well, we're probably going to put this together and take it apart a few times, so let's just go ahead and put it together. Just looking at some scratches on it here, wondering if I should... Oh yeah, right. Righto. Got to take the knob off. Righto, that's British. Did anybody know that? Okay. Oh, come on. Get on there and stay on there. Good enough for now. Now, we'll see what happens when we put this back. Put this back in its case. Gets it up real snug in here instead of leaving this gap. Wow. I don't know. I have to push pretty hard at the back, and I think I'm just bending the front here a little bit. There's a big gap there. Let's turn it on. See what it looks like. No, speaker's right in here. Looking for a speaker. There's one in the radio. clip lead that doesn't want to clip. Okay. Get a chance to see what the front looks like in the cabinet too. Switch on. Switch on. Oh, I think I know the problem. I never plugged the cord into the radio. Switch off. Okay, now we're ready. No. See that? See that? Just an angry no. Fixed it. Shut off a few lights here. See what we got. For light leakage. Bit of a focus issue there. Here we go. Well, I don't see any leakage of light, really. Nothing from the bottom here. Nothing from the top at all. It's all coming through just like it should. So, no problem with that. Now, what about... maybe when I put the cabinet in, I can squeeze it up a little tighter. I think that gap is just going to be there. I think. Some more glue to remove. And then how is this radio was screwed in with 2 screws in the bottom, and then it needs feet. It needs feet. We have to give it feet. Okay. Let me find some feet. I think I have a bag of feet. Bag of feet. Right here somewhere. Where'd it go? Okay, so bag of feet has gone somewhere. Here it is. Here, I have it out here ready. Bag of feet. We need 4 feet. Four identical feet. Here I can see 4 of these nail-on type here. A bunch of white ones. Got 4 of these. This type. These are hard as rock. What else have I got here? 1, 2, I got 4 of these. Okay, and I got 4 of those. More like this. Now, the screws on the bottom stick out. At least the ones that were in there. Here they are. They just stick right out of the bottom. So you have to clear that. I think that would do it. Pretty close. I think that would do it though. And the other, I don't want to use the nail-in ones. So I have these, and then I have these. These ones are about the same. Okay, so these guys win. Now, to do this, I gotta take the radio out. This here, what kind of feet did it have on it? So it looks like it has the kind that you put a big bolt, like screw bolt through. So I could simply screw these with a wood screw near the holes. I think that's what I'm going to do. Rather than try to arrange some bolting arrangement. There's no need for that. So we need some little wood screws. Small ones here. These are all going to be too big, I think. Yeah, that's good. This is quite a thick piece of wood here. Actually, you know, if you there's another piece of wood glued in right above here, which is probably the runner for the radio chassis up on top. So if you put a screw in here, you got a lot of wood to go in. But even the main board is really quite thick. That would work. I think the screw is too big. It's kind of a light duty job anyway. I need some smaller screws. So I'm going to hunt them down, stick those feet on. Okay, last foot. Darn Phillips screws. Oh yeah, the other three went in zoom, zoom, zoom. This is the one I've decided to put on video. Let's try a different bit. Not quite so wiggly. Oh boy. Okay, I got it. I think that was the end of that screw too. Okay, there we go. 4 feet. And great. So what I'm doing now is I'm trying to get rid of the gap in here, which isn't very much actually. So I'm locking down, there's 2 screws that lock down the cabinet underneath here. Just getting the screwdriver in. Okay, and then I'm just going to push this forward and try to lock it. There it is. There's no annoying gap in there at all. That's great. Now I got another challenge with this radios. One of the knobs came without its set screw. So I don't know if I got a set screw that's going to fit in there. I might have to end up putting different knobs on this radio. Okay, set screw hunt. Oh my gosh, where do those little guys reside? Well, that took a lot of hunting. I have a pretty good knob collection. This is just a small part of it here. And I finally found a set screw which will screw into the knobs for this radio. Great, because I really didn't want to put different knobs on here. Okay. think I'm tightening it. Maybe not. Can't quite. The knob is in too far. Oh, I tightened it. Got a piece of it there at some point. There. There we go. Now, these knobs have a brass ring, which you probably saw earlier. Brass rings means you can tighten the screw fairly tight. Okay, let's see if we can. How am I going to get the screwdriver in here? This knob's in the way now. I guess something like that. Okay, screw's backed out. There. Here we are. I can feel it tightening. Good show. Is it tuning? Yes, it is. Hallelujah on that. You know, if this sat for 6 months, you might go to tune this and it will be stuck again. But wow, it feels great. It really feels like I got past the stickiness. The pointer is ending right in the right spot. Wonderful. Now the last thing really is hooking up the speaker properly. Here. Whoa, 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 whoa. Don't fall over. We also need to plug in this. I'm going to plug it in right now so I don't forget. I'll have to unplug it to put the back on. That's okay. Forget. Probably wouldn't forget anyway. Bring this over. Okay. One. The other one's kind of short. Ah. Yeah, I'm going to knock that off. Let's solder that one before I'll knock it off otherwise. Very short wire here. Short wire, clumsy fingers. Now, did you see that? See that reflex? I dropped my solder to the floor while holding this. The reflex was I let go of it. Otherwise, I'd have 14 feet of solder. Isn't that amazing? It's just amazing. The human mind. That dingling you're hearing is my cat scratching at its bell collar, wanting to go outside, I'm sure, but I'm not going to do it right now because I'm just about to test this. Hang on, little shadow. I want to just put a little tape on at least one of those. I don't think there's any chance of them shorting, but there we go. Okay, let's give this guy a listen now. See where we're at with it. This is plugged in. See what it looks like on its nice feet. Look at that. The hold down screws are way off the surface, so they're not going to scratch anything. The feet were big enough. Excellent. Power cord in. Okay, switch is off. Power's on. Let's darken it down a little bit in here. Ooh, that's quite dark. That's quite dark. Yep, almost lunchtime. Here we go. Whoops. Okay, sorry about that. Was that as exciting for you as it was for me? In the dark here. I'll tip it up and take a look at it. So, I mean, there's definitely the pattern of the lights, but it's actually attractive. A little better with my eyes. And my soldering iron on the radio. Let's tune in the dark. Like that song.
Like astrology, bending or breaking the rules his entire life. Now he said, stick with the rules.
Not sure what that is. French on FM.
A light just went on, and you said that sounds perfect. But there's also a number of other ministries that are on there. And if you'd like to put your job on, you can do that anytime or look for a job. Lifeonline.fm.
It's definitely some strange stuff. Beautiful sounding radio. It really is. You know, when you're going to get a vintage FM radio, yeah, I think it's wise to stay away from a stereo type radio. And you're smarter off to buy a mono. If you're going to do this, buy a mono FM radio. The chance of you getting excellent sound out of a mono FM radio of this vintage is much, much higher than a stereo. And what do you need stereo for, really, when you're looking at a tabletop type radio? So let's just check FM now. FM. Let's check AM. Fantastic. Antenna's not super directional. Excellent. I think that's the end of this radio. I think that's the end of the journey with this one. So, very nice radio, I think. Great. Okay.
That's done. That's great. I'm a little surprised. I'm done. I am done though. So thanks a lot for watching this series, and I gotta pick another radio to work on in here. See ya.